So, ladies and gentlemen, the directions are going to be the same throughout the entire lesson, okay? We're going to establish the identity, all right? And within each box of the 4 boxes that I have, with regards to the last one, there's going to be 3 problems we're going to do per box, okay? So the directions will be the same for each one. We're going to establish the identity. Now, the way that we do this, okay, is that you need to pick a side and stick to it. Okay, so what I mean by that is there's a couple of rules that you have to play by, and one of the rules is we are not allowed to work across the equal sign when we are establishing identity. So what I mean by that is there's a left side, which says secant theta times cotangent theta, and there's a right side that says cosecant theta. And our goal is to prove that either the left is the same as the right or vice versa. The right's the same as the left. So the general rule is you want to pick the side that looks harder or more challenging because that's the side that's going to have more stuff to work with. Does that make sense? Kind of? Okay. So that's one rule there. The other rule is generally, if you can, you want to change your identities into sines and cosines. They're generally easier to work with, right? This is what I would call a bunny slope problem. And I'm going to go ahead and say that the left-hand side is the side I'm going to start on because there's more stuff to work with on that side. Does that make sense? Okay, so this says secant theta times cotangent theta is equal to cosecant theta. So make sure you have your toolkits out. We're going to be using those, all right? Toolkit is that piece of paper, that toolkit that we have, okay? All right, so what I see right here, I'll do this one, sort of model it for you. So secant theta. Taking a look at secant theta, I can rewrite the secant theta as 1 over the cosine of theta. I'm allowed to do that, right? That's a reciprocal identity. Secant theta is the same as 1 over cosine. And cotangent of theta is the same thing as the cosine of theta, all divided by the sine of theta, because that's the quotient identity. All right? So I have 1 over cosine times cosine over sine. Does anybody see anything nice that happens here? Yeah, very good. The cosines cancel out, leaving me with a 1 divided by a sine theta. 1 divided by sine theta, according to our reciprocal identity, is equal to cosecant of theta, which is exactly what we were trying to prove. All right?
How did you know that 1 over
All right, cosecant theta times tangent equals secant theta. All right, first of all, which side do you want to work with, the left or the right?
left?
Let's work with the left. I agree. More stuff over there. Anybody see anything we could do?
1 over cosine.
Good. Cosecant is equal to what?
1 over cosine.
That's 1 over sine theta. Very good. And what's tangent theta equal to? Tangent theta?
Oh, sine theta over cosine.
Very good. Is sine theta over cosine theta. What do you notice? Sine thetas cancel out, leaving us with 1 over cosine theta, which equals secant theta, which is exactly what we were trying to show. Now in the book, you guys, you might see t's or betas or x's or whatever. I like thetas. I'm really partial to those, so I'm going to use those a lot. But in the book and other classes, just know they can be replaced with whatever. Okay? All right, so I'm seeing a negative angle in here, so we're probably going to use which identities? Even and odd identities, right? So the cotangent of negative theta, what's that equal to?
Negative cotangent.
Yes, this is equal to negative cotangent theta times sine theta. Good. Okay, now what can we do? Anybody see anything that's useful? This is why that toolkit is super helpful. Negative cotan theta times sine theta. Cotangent is what?
Tangent, 1 over tangent.
It's cosine over sine.
It's cosine theta over sine theta.
But if it's cotangent, isn't it 1 over tangent?
Okay, now, she makes a great point. Isn't cotangent 1 over tangent? The answer is yes, and we could put that in there. But does that get us closer to what we're trying to establish? Not necessarily. It adds an extra step. And right now it's hard to see that because we've only done 3 of these in our entire life. Okay? But the more that you do them, the better you get at them. And I'm taking advantage of the fact that it's a good idea to change things into sines and cosines rather than changing things into tangents. Okay? So I have the negative of cosine over sine times sine theta. Anybody see anything interesting that happens out here? Sine theta cancel with sine theta, leaving me with a negative cosine theta, which is exactly what it says right there. All right, this is a green circle. All right, this is what I've defined as a green circle. So I have sine theta plus tan, or sine theta times tan theta plus cosine theta equals secant theta. All right. What side do you want to start on? Left or right? I say left too. It's a good call. All right, let's change everything into sines and cosines. Okay. So far, I have a sine theta. If I change tangent to sines and cosines, what do I have? Good. Sine theta over cosine theta. And then I have a cosine theta, and that's over 1, right? Even though it's not there, it's still over a 1.
Why isn't sine theta over?
I could put that over 1 too. Right? Do you realize that that's all the same stuff? Yasmin, what's up?
So if it's cotangent, you would put cosine over sine?
In there. So sine theta times sine theta is sine squared theta over cosine theta plus cosine theta over 1. Notice where the squared goes. It goes in between the trig function and the angle. All right, so now how do you add two fractions together?
So would you make the bottom the common denominator?
You need a common denominator. Very good. So what does the left side need? Yeah, you need a cosine theta over a cosine theta, right? After all, you're allowed to do that because that is a fancy 1. You're allowed to multiply any term by 1, and you're allowed to make that 1 whatever you want. So in this case, cosine over cosine is going to help us out a lot. Here's what we get when we do cosine over cosine. Where's my orange? There we go. Pen. Boom. Okay. So I get sine squared theta plus, what's cosine times cosine? Cosine squared theta, all divided by, what's the common denominator, guys? Cosine theta, right? Just cosine theta. All right, now, the numerator, sine squared plus cosine squared, that's famous. That's a very famous identity. It's equal to what? Nice job. So sine squared plus cosine, all of this right here is a Pythagorean identity that equals 1. I still have a cosine theta on the bottom.
1 over cosine theta.
And 1 over cosine theta is what? 1 over cosine theta is secant theta, which is exactly what we were trying to prove right there. So I'll shrink the problem down so we can see it. And there. All right, Bailey, what do you got?
Verbally?
Yeah, go ahead.
Alright. So first, just to make everything look the same, you're going to put cosine theta over 1.
Okay.
And then times cosine theta over sine theta because that is what cotangent equals.
Okay, good.
And then plus sine theta over 1.
Good.
And then you can combine, you can multiply.
Yep.
And so you're going to go cosine squared theta
Yep.
over sine theta
Yes.
plus sine theta over 1. And then to make the denominator the same, you're
Mhm.
going to multiply by 1 or sine theta over sine theta.
Good.
So then you're going to get cosine squared theta plus sine squared theta, which is equal to 1 over sine theta. So then you get 1 over sine theta, which equals cosecant theta, which is what you're trying to
1 over sine theta, very good. Which is equal to cosecant theta, which is what we were trying to show right there. So shrinking that down, there's the entire problem. You did an awesome job, babe. All right, I'd like you to try this one on your own. Write it on the desk before your notes, and then rate it. It's either going to be a bunny slope or a green circle. I want you to rate it however you feel like it is. All right, ready to go. Cindy, take it away. What'd you get? Yep. So you said this was cosine theta over sine theta. Okay, good. I like that. Then what? And then secant is 1 over cosine theta. Good. Okay.
And then I added sine.
Yep. Sine theta over 1. Good. Then what happens?
And so then the cosines cancel.
Cosines cancel out?
So then it becomes 1 over sine.
Yep. 1 over sine times sine. Thetas, right? That cancels out, leaving me with 1 over 1 or 1, which equals 1. So you guys, most people rated this as a bunny slope. There it is. Ooh, that's better. Hey, there we go. Okay. Cindy says we could factor out a cosine theta. She's right. Check this out. If I do cosine theta, right, then what am I left with? I'm left with 1 minus sine squared theta. Does everybody see how we did that? Okay. I'm factoring out. Look,
Option somewhere.
see? Cosine there and a cosine there. I can factor out a cosine,
Oh.
leaving me with a 1 minus sine squared. Do you guys see it?
Ooh, so it's cosine squared.
Very good. And then what is 1 minus sine squared?
Cosine squared.
Very good. So I have cosine theta times cosine squared theta. And what's cosine theta times cosine squared theta?
Cosine cube theta.
Cosine cube theta, which is exactly what we're going for. We're up. Go.
Alright, so you factor out a sine.
It says factor out a sine theta?
Yeah, sine theta.
Yep.
And you get 1 minus cosine squared theta.
Good.
Yeah, okay. And then that equals sine squared.
Yeah, good. So 1 minus cosine squared theta is equal to sine squared theta. And then what's sine theta times sine squared?
Sine cube.
Sine cube theta, which is exactly what we were going for right there. Awesome. All right, now solid green circle. I would like you to either pick the left or right. This one can be done easily on either side. So pick a side and go for it, okay?
Can you do can you multiply?
Okay, Seth is going to explain his solution from the left-hand side. Everyone pay attention, por favor.
Okay,
Go ahead.
So first you take the left and you can split it at the plus sign.
Yeah.
Make it 1 over cosine theta plus sine theta over cosine theta. And 1 over cosine theta equals secant theta.
Yeah, 1 over cosine is secant theta. Very good.
And then sine theta over cosine theta is tan theta.
It is tan theta, which is exactly what you're looking for. Okay, so that was pretty easy if you go from that side. Could you go from the right-hand side? Yeah, if you went from the right-hand side, so here's what I'll do. I'll draw a line right here. If we go from the right-hand side, what is secant theta equal to? I think, Holland, you got this one right?
1 over cosine.
So this is 1 over cosine theta. Good. What's tangent?
Sine theta over cosine.
San theta over cosine theta. Good.
And then you would add those two to equal 1 plus sine theta over cosine.
Good. So either way, you guys, you end up with the same thing. That's what's so cool about these problems is there's a variety of ways to do them. As long as you stick to the rules of algebra and math, you're gonna be doing it just fine. Okay. Okay. This is the official you try of the lesson. Go ahead and try. Here's what we have. This is the official first blue square. This is the highest we're gonna go today. It is cosine theta over 1 plus sine theta plus a 1 plus sine theta over cosine theta equals 2 secant theta. So ladies and gentlemen, what side are you going to work from? I say the left. Okay, that's a good call. Now, here's a hint. I want you to do algebra stuff first before you try the trig identities, all right? So I want you to write it on the tables with your expo marker and try anything that you can. Just try it before we start talking about it, okay? I want you to actually mull over this one, okay? Ready, set, go. Seth, you're up. Go for it.
Can I use that thing?
No, because it's going to be recorded. You tell me what to do, though, and I'll follow along.
So you multiply, or we're working from the left side?
Yep.
You're going to multiply that one by cosine theta over cosine theta.
Yep. Multiply it by cosine theta over cosine theta. And then this one?
By 1 over sine theta over 1 over sine theta.
Good. So 1 plus sine theta over 1 plus sine theta. And we want this to be a 2 secant theta. All right. So on the left, what does that give you?
Cosine squared theta.
Yep.
Over cosine theta.
Yeah, but I'm going to have one big denominator here, right?
Yeah, plus
Yep.
1 plus sine theta.
Whoa. Okay. 1
1
plus
sine theta.
sine theta. Quantity all squared. Good.
Over cosine theta
Mhm.
of 1 plus sine theta.
All right, good. Everybody follow along with that so far? All right, good. Now, what do we do?
Then you FOIL the 1 plus sine theta.
All right, so we're going to have cosine squared theta plus, this is going to be 1 plus 2 sine theta plus sine squared theta. That's probably the hardest part, I think, seeing that. And then all over, where were we at? Cosine theta times a 1 plus sine theta. All right, pick it up from there, dude.
And then you can add the cosine squared theta to the sine squared theta.
Yeah, so this piece and this piece equals what?
1.
Yeah, very good.
1 plus 1 plus 2 sine theta, which is 2 plus 2 sine theta.
Good.
Ah.
Mm-hmm. Okay. So that gives me 2 plus 2 sine theta all over cosine theta times a 1 plus sine theta. Then what?
And then you factor out the 2 from the top.
Good. 2 times a 1 plus sine theta all over cosine theta times a 1 plus sine theta. Then what happens?
Then you cancel out the 1 plus sine theta.
Ooh, yeah. Giving you 2 over cosine theta. Then what happens?
And you can move it back to the front.
Yes.
So it's
2
2,
times 1 over cosine theta.
which is equal to 2 secant.
Whoa, yeah, which is what we have way back up here.
Wait, can you go down a little bit?
I will. I want to actually, whoa, we're way up here. Whoa, take a detour. Whoa, take a detour up there. Check it out. There's the whole problem.